Hello, welcome here guys. The video you're about to see is taken from a full course you can find on academy.inco.com. So if you're looking for more context, more lectures, more videos, more explanations, you can find for sure there. And now you can enjoy the video. Hi there, welcome here guys. In this lecture we have done small changes in our React applications. Basically we have just removed some of the JSX and we have this empty hello world application. In this lecture, I'll continue and I will start talking about blockchains. This lecture will be marked as the AI lecture. This means our additional information lecture. These kind of the lectures are completely optional. They are skippable. If you feel like that you understand the topic or you already have information about the topic, you are free to skip AI lectures. I will be explaining only theoretical stuff. I will be drawing on the board. I'll be not doing any coding. Okay, so this is one of the AI lectures, so feel free to skip it if you already have information about the blockchains. For those ones what are staying here, we can start talking about the blockchains. All right, so I'll get to my drawing board and I'll be drawing. First, I will show you the example how the transactions work in a normal banking system, and then I will show you example how it would work with the blockchains. I am pretty sure you already heard about the term about the Bitcoin. I am sure you heard about Ethereum. Both of these names are related to the digital currencies, but also to the term of the blockchain. So let's first explain banking scenario, then we'll get into the blockchain scenario. Okay, let's say we have two persons. We have Alice and Bob. Both of these people wants to open a bank account in a bank. So we have this entity, we have a bank entity that's governed in some specific state, in some specific country. They have an issue to, they don't have an issue, but they are allowed to work as the bank. They got this permission by the state or by the country where they are operating. So we have Alice, and we have a Bob, and both of these people wants to open the bank account. So they will go to the bank, they will provide their private details, they provide their name, the place where they are living. In some of the banks, when you're opening some specific bank account, you need to also provide where are you working, what is your income, and all of this information. So okay, so we have a Bob. Bob is opening an account, and we have Alice, and Alice is opening account in the bank. So here I will mark the banking database. So there is some kind of a banking database. Let's say it's called My Bank, and Bob opened a bank account. Also Alice, Bob put a deposit of let's say $300. We're talking about the dollars, and Alice plays a deposit. Initial deposit of $500. So Bob has a $300, Alice has a $500 on the bank account. When the Bob wants to send the money to the Alice, he has to go to the bank to create a transaction, or he can use nowadays you have applications in your phones, or you have a website of your bank where you can send the transaction. So Bob will go to the mobile application. So we have here Bob, and he will access his mobile application. Let's say, oops, that's not very straight line. So he will open, let's say we'll call it My Bank application, and he wants to send some dollars to Alice. So he will make transactions. Every bank is keeping a ledger of the transaction. So let's say Bob wants to send $200 to Alice. Okay, Bob made a transaction. It's sending $200 to Alice. This transaction is verified by bank. It's verified if Bob has enough of money to send $200. Also, the identity of a Bob is verified, and also all this stuff is verified. So Bob can make a transaction of $200 to Alice if it's verified by the bank, by the central authority of a bank. It's verified that it can be sent. Everything is good. It can be sent. Transaction is confirmed, and money are sent to Alice. Okay, so Alice has now plus 200 and Bob has minus $200. So the database in the bank is updated, right? Bob doesn't have any longer 300. He has now 100 because he sent 200, and Alice received this 200. So Alice doesn't have any longer 500, but rather $700. That's how it worked on the base level with the bank. We are opening account, we are placing some money when we want to make a transactions. We are using applications where we are authenticated as the users, or we are going straight to the bank where we need to verify ourselves as the owners of the account, and then we can send the money. In this case, $200. Bob is sending to Alice, and is kept on some ledger, right? This is my bank ledger. Okay. Bob is sending transactions, and the transactions went through because it's verified by the bank. So as I told you, bank is just a company. They had a permission by the state to operate as the bank, and also they give you guarantee that the transactions will be rightfully confirmed, and that your money just don't disappear randomly, and that you can make transactions with the money, and you have also the security that your money just don't go away. Okay, so that's how it's working with the bank. Okay, so let's explain our example how this would work with a blockchain. Okay, so first we need to answer the question, what is a blockchain? All right. So blockchain is simply system or a platform in which computers are connected with each other. They are following some specific rules. We mentioned before that we have a Bitcoin, we have a Ethereum. In this case, if you will understand Ethereum, you will not have any problems to understand Bitcoin. So I will be talking about Ethereum. Oops. Oh, okay. Ethereum blockchain. It's my first drawing actually on the board, so I'm sorry if there will be some mistakes. Okay, Ethereum blockchain. In the Ethereum blockchain, we have a digital currency. As we have with the dollars, euros, Ethereum blockchain is issuing Ether or ETH currencies. So we have a digital currency. We have a Ether or Ether. Okay, ETH, Ether. It has some value on the markets, but we'll be talking about this stuff later. Okay, so we have the Ethereum blockchain. I will go we'll be talking about the basic stuff. I will not be talking about the specific stuff. I just want to get you some base model in your minds, so we can talk about more specific stuff in the next lecture. So just some base level information doesn't have to be specifically right or specifically truth on the specific level, but as this high view or as this overall view, these informations will be giving you the details how a blockchain works as the initial lecture. Okay, so you can imagine blockchain, as I told you, is working on the internet. You have a connected computers together. So we have this blockchain. You can imagine this as the computers connected with each other. So we have a computers, this one computer, all right, the second computer, they're connected with each other on the internet, okay? I'll just mark here these squares. It is simply blockchain. All right. Or this is not specifically the blockchain, but it's a blockchain system. We will be talking about why it's called blockchain very shortly. Okay, so these computers are connected with each other, but how they can be connected on the internet? Of course, they has to run some kind of a software. They have to run some program that it's connecting them with each other, and that's right. They are running some software. When you want to connect to the blockchain network, you need to run on your computer some specific software. Either you have this, they are called clients. Okay, I'll mark it here. Clients. When you want to connect to blockchain, you need to run some clients, some applications, some software on your computer. You have many of these implementations of this software. You have Geth, for example, that's written in a Go language. That's a Go language. And then you have, for example, Parity. You have also other ones. You have a lot of them. Parity. and this is running, this is programmed in the Rust programming language, and you have also the other client. So when you want to be as your computer, also your notebook or your personal computer, you can connect to Ethereum blockchain. Okay, this is the Ethereum blockchain here. Okay, so you have to run this specific client. Okay, so I'll mark here you have to run the client. Okay, this will be client, and all of these computers, they are running these clients. Okay, and these clients they are connecting with each other. Okay, and we'll not refer to them as the PCs. They are of course the computers here, but we'll not refer to them as the PCs. But in the terminology of the blockchains, you will rather call these nodes. Nodes. Okay, nodes. One node, this other node, and all of these nodes are connected with each other. Of course, also blockchain has to keep some kind of a database. Who has how much money, all right? So when I would like to be a part of a blockchain, I would like to make transactions on the blockchain. Okay, that's one of the things I didn't mention. As a bank, you can make transactions, keep your money safe, and so on. You can do the same stuff on the blockchain. You can keep the money. In this case, in the Ethereum blockchain, you can keep it Ether, okay? And you can also send the transactions to other people. Okay, so blockchain has to have some kind of state, all right? So, of course, there is some kind of a database. All right, database. Let's call it database in this case. We'll be talking about the specifics about this database later. It's not really a database in true sense, but to get your base level, let's say it's database, and this database will be maintained by everybody that's connected on the Ethereum blockchain. So all of these nodes are keeping track of the database, and this database is true for every node, and every node has to keep the same state of the database, okay? Because Ethereum blockchain is keeping the singleton state, okay? So Ethereum blockchain is keeping singleton state. Okay, because one node doesn't have other state as the second node. Okay, so this has to be the same for every node. So all of them they keeping track of with the same database. So Bob has some Ether, and all of the nodes knows about it. Of course, they don't know the Bob because, as in a banking, you have a banking number. In Ethereum blockchain, you have an address. I'll be talking about which address you can create later. Okay, so we have here. I will be just. I'll be calling our participant in a blockchain as Bob with Alice, and also other participants. And of course, you don't have their true names when they are connected, when they are on the blockchain. Okay, you have rather, as in a bank, you have this banking number. In the blockchain, you have an address, and address is a 20 bytes a number. Okay, in hexadecimal format, let's say 1, 2, and so on. And here is 0x and 4, 3, and so on. And you have 20 of these bytes. You have 20 bytes. Okay. So here the database, and let's say Bob has. Okay, let's talk about addresses later. So let's say Bob has some Ether, and also Alice has some Ether. Okay. So Bob has 4, and Alice has 5 of ETH. Okay. Okay, so when Bob wants to make a transaction, let's say Bob is making transactions. Bob is sending to Alice one ETH. When he's making these transactions, also Bob has to be connected to the blockchain, or he has to make a request to some other computer, and this other computer has to be connected to the blockchain. But let's say the Bob is connected to the blockchain, and he's making these transactions of 1 ETH. He wants to send 1 ETH. These transactions will be sent to the nodes in the blockchain. Okay, so these transactions will go here, and all these nodes, this transaction will be sent to all of the nodes on the blockchain. And this transactions will be not yet, there will be not ETH transferred. The Alice will not immediately receive ETH, but this transaction will be added to the pool of other transactions. So the part of the blockchain is also pool of transactions. So you can imagine also the blockchain, there is some, you can call it, it's called Mempool. Actually, we can pool of transactions. you will refer to this as a mempool. All right, this mempool. Okay, and you have these transactions that Bob made. This is the transaction. Transaction is added to this pool. Okay, so here are these transactions amongst the other transactions. Okay, so you have lots of transactions. There are thousands of transactions sent every day. So this is added to the pool of these transactions. So how actually Bob can transfer his ETH to Alice? Okay, so in the transactions to be added into the blockchain and to this database that is maintained by every node it can change, the transaction has to be added into the block. The block is just a structure that's keeping the structure of the verified transactions actually. Yeah, I will be drawing it, so let me draw it here. So the transaction has been emitted and is transferred through all of the nodes and added to mempool. Every kind of a node is different. You have different types of nodes, but there are specific nodes called full nodes. Full nodes keeping the entire database of the blockchain, and also they can mine transactions. They are referenced as the miners. I'm sure you have heard about the miners. So the miners are just simply computers. Other computers in the blockchain, I will refer to them as the miners, okay? And they're running full nodes, and about the types of nodes I will be talking later, okay? So they're also connected with the other nodes in the chain. And they have access to mempool. Every node has access to mempool. Every full node has access to mempool. And they can add transactions into blockchain. Okay, how they can do it? So they're running software, and the software is doing actually for them. But simply what they will get a specific number of the transactions, and they will verify them. Okay, so they will get some transactions from the mempool. They will get these transactions, and they will order them. So they will get the transactions, they will order them and verify them first. After they are verified transactions, they are ordered, they can add them into the block, but in order to add them to the block, they need to solve some mathematical puzzle. Actually, they have to find some specific number. It's a very huge number, and it takes some time to find this number. It takes some computational power of your computer to find these numbers, because you need to run some algorithm, and this will take some computational resources from your computer. It takes, I think now its average time on the Ethereum blockchain is 15 seconds to find the answer. Okay, but yeah, actually you can imagine this actually not as this structure as a draw here, but you can imagine it as the block. Okay, so they are trying to create a block of transactions, and they will order these transactions here, and they are looking for some specific number. About the details we'll be talking later. Okay, so they are looking actually for a number called nonce number. When they will find the answer, there are a lot of miners competing with each other to find the first answer. Okay, so there are order transactions. They will find the number, and after they will find this number, they can add a block into the blockchain. So the blockchain also keeping the track of all of the blocks that have ever been added into the blockchain. Okay, so you have also all of the blocks that have ever been added to the blockchain, and that's the name, okay, blockchain, because their blocks are connected with each other. Okay, so there are blocks of the transactions. Blocks of the transactions. They're connected with each other. All right, transactions. And when the miner will find the answer, he can add a block into the blockchain. So now this block can be added here. So he can add the block in the blockchain. Of course, the blocks is also verified by other participants in the blockchain, but let's say this block is now valid and it's added into the blockchain. And let's imagine one of these transactions here, we're sending money to Alice, the transaction that went initially to the mempool that the miner has mined and added to his block, and then when he finds the answer on the block, can be added to the blockchain, and this will also update the state of the Ethereum. update the database. It will be updated amongst all of the other clients in the network, amongst all the nodes in the network. Okay, so this block will be added into the blockchain. This will be updated. So Bob sent ETH, so it will have 3, and Alice will have 6 ETH. Okay, and Bob has 3 ETH. Okay, so on a very, 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 very base level, that's how it works. So we have an Ethereum platform, we have an Ethereum blockchain is the network of connected computers. We are calling nodes. They are running some specific software, can run a gap or a parity. And with this software, you can connect with all the other nodes to this network. When we want to send the transactions, we need to emit the transactions into the network. For example, we are sending one ETH from the Bob to Alice. This will be added on the mempool on the blockchains. So the nodes that are participating in the network, they can get the transactions, and they are trying to form from the block. So the block can be added into blockchain. As soon as the block is added to the blockchain, and it's considered as a valid block, then all the transactions also will done the changes to the state of the Ethereum blockchain. Okay, so all of the accounts and the transactions that have been sending money, that they will update this singleton database. So this will be Bob will have a 3 ETH and Alice will have a 6 ETH, and also this will be then synchronized through all of the other clients. So now you can see this difference: the centralized bank and decentralized Ethereum blockchain. With the bank, we can send the money. Also with the Ethereum, we can send the money. But with Ethereum, we can also we can do other things. I will be talking about this in the next lecture. So with the bank, we need to provide our private details. It's a centralized. It's a trusted governed by state and also protected by the state. So your money are basically protected like this. But in exchange for these benefits, you are basically dependent on the bank, on the changes what are done in the state on the bank, because the state it shouldn't happen, but the state can say that now there are some new rules, or maybe there is some inflation, that your money is losing the value, and so on and so on. But I don't want to talk about these things. I just want to the main point is here the bank is a centralized structure. Comparing to Ethereum, blockchain is a decentralized because it's run on thousands of clients, and your transactions are confirmed by other computers. And these computers, in order to get the transactions to be transactions valid, and also the money can be sent, the first node that will find the answer to some specific to some algorithm, it can add these transactions to the block, and therefore the transactions will be reflected in the state of the blockchain. Okay, so how can we trust the system? We'll be talking in the next lectures. This system, I need to tell you from the beginning, is very secure. All the transactions are verified by the thousands of nodes, and also there are some protections, mathematical methods, and crypto methods that are issuing. This is close to 100% secure. Okay, so about all these details we'll be talking in the next lecture. I already explaining here quite a lot of time. I will drop some resources for you in the resources of the lecture, some videos. You can watch something about the Ethereum blockchain or about the blockchains. Overall, what I would like to get to your mind is it's just a software, it's just some platform, and it's working thanks to the cooperation of the thousands of people that are connected with each other, and they are creating this kind of network. If any questions, ask them. Let's continue next lecture, and I promise not all of the lectures will be that long. Thank you for staying here, and let's continue in the next one. Cheers.